Now discuss oxidation number in covalently bonded state or covalent bond. If there is a covalent bond, then how can we find oxidation number? So rule number 1, or you can write this in node point number 3. Node point number 3 after maximum minimum oxidation number. Okay, oxidation number in covalent bond. For covalent bond, just consider two atom A1 and second one is B. Atom AA, there is a bond between atom BB. If there is double bond, no issue. Okay, there is a single bond between AB, there is double bond between AB, and there is triple bond between AB. 3 bonds are present. Okay, and let us assume electronegativity of A is greater than B. If electronegativity of A is greater than B, then what is the oxidation number of A and B? In this case, electronegativity of A and A are same, so oxidation number is 0. In this case also 0, and in this case also 0. Same element, so there is no electronegativity difference is present, so oxidation number is 0. In case of AB, the electronegativity of A is high, so A gets negative charge and B gets positive charge. This is hypothetical concept. Okay, imaginary concept. There is a single bond, so A gets -1 and B gets +1. In case of AB, this is -2 and this is +2. In this case, A gets -3 and B gets +3. Okay, the element whose electronegativity high gets negative sign and the electronegativity is low gets positive sign, and for single bond, that is -1 and +1, -1 +1, double bond +2 -2, triple bond +3 and -3. Consider this example, carbon dioxide. In carbon dioxide, if you calculate oxidation number of carbon, then you can write this carbon as X and oxygen is -2, so -2 into 2 equal to 0, so X minus 4 equal to 0, X equal to +4. Okay, also this can be found in this manner by using bonding situation. In case of carbon and oxygen, right, carbon and oxygen, here oxygen electronegativity of oxygen is high, so oxygen gets -2 and carbon gets +2. In this case, in this carbon and oxygen electronegativity of oxygen is high, so oxygen gets -2 and carbon gets +2, so your total positive charge on carbon is +4. In this case also +4. Yes or no? Okay, another example number 2. Example number 2 is, let us consider H2O. In case of H2O, H2O oxidation number of X, oxygen is X and hydrogen is +1 into 2 equal to 0, so X equal to -2. Oxidation number of oxygen is -2. If you write the formula, this is the formula. Here oxidation number of oxygen is -1 and here +1, because oxidation number of oxygen is -1. Why? Here electronegativity of oxygen is high and electronegativity of hydrogen is low. In this case, hydrogen and oxygen, electronegativity of hydrogen is low, oxygen is high, so oxygen gets -2. Consider another example, H2SO4. H2SO4. Here oxidation number of sulfur. Sulfur is, you calculate oxidation number of sulfur, 4 into minus 2, and this is your plus 2 equal to 0. So x minus 6 equal to 0, x equal to plus 6. Here oxidation number of sulfur is plus 6, means when sulfur combines with hydrogen and oxygen to form H2SO4, imaginary sulfur loses 6 electron. If you find oxidation number in, if you covalent bonding state, this is a covalent bond. In covalent bond, for the top, this sulfur and oxygen electron to oxygen is high, so oxygen is minus 2 and sulfur get plus 2, and for this sulfur and oxygen, sulfur gets plus 2 and oxygen gets minus 2. And for this right side, sulfur and oxygen, there is a single bond, so sulfur gets plus 1 and oxygen gets minus 1. And for this left side, oxygen and sulfur, this gets minus 1, this gets plus 1. So total charge on sulfur is plus 2, plus 2, plus 4, plus 5 and plus 6. So oxidation number of sulfur is plus 6. In this way you can find oxidation number in covalent bond. Okay, I think we have cleared this concept. Okay, next point is oxidation number in coordinate bond. In coordinate bond or dative bond. Okay, this is the example. If two atom, we just consider two atom, A coordinate bond with B. A means here the electron pair given by A and accepted by another A. Coordinate bond is formed between BB. Coordinate bond is formed between BA, and coordinate bond is formed between your AB. And also assume if electronegativity of A is greater than B, then here electronegativity in both the cases are same, so oxidation number is 0 in A. If you assume this, then this is not true. This is coordinate bond, this is not covalent bond. In covalent bond there is no electronegativity difference, then you can write oxidation number is 0. This is coordinate bond, this is the arrow mark. Okay, in this case electron pair given by first A, this A and this A, and electron pair again by this A. So this A gets minus 2 and this A gets plus 2. In coordinate bond, when you assume, then there is a minus 2 charge, there is minus 2 charge on that atom which gains electron. In this case it gets minus 2 and this gets plus 2. Also in this case this is minus 2 and this is plus 2. Here electronegativity low, here electronegativity is high. Okay, in this case electronegativity is high for A and electronegativity is low for B. Okay, electronegativity high and electronegativity low. Okay, when electron is donated by the higher electronegative atom, in that case or in that scenario, you could not write minus 2 and plus 2. Here no charge is 0. This is an important case. Okay, if electron pair donated by the atom having high electronegativity to the atom with low electronegativity, then there is no charge. Okay, next point number 3, all element, point and last point, all elements in alloy has 0 oxidation number. Okay, in case of alloy, when alloy is formed, alloy is a homogeneous mixture of two metals, more than one metal. And in case of amalgam, if you write NaHg, this is called sodium amalgam. This is sodium amalgam. What is amalgam? Amalgam means that metal, sodium amalgam means sodium metal, it dissolved in mercury. In this case, oxidation number of sodium is 0, dipped in mercury. In case of zinc, this is called zinc amalgam, its oxidation number of zinc is 0. Okay, I think you have cleared this concept. It completes your calculation of oxidation number. If any doubt, you can ask. Thank you.